Now what we're going to do is we are going to begin the part of this course that I colloquially refer to as the boring part of the course. In my opinion, the stuff we're going to learn about the solar system, other worlds, the planets around other stars, life in the universe, I think that stuff is much more interesting. But the NU course catalog says we do need to spend some time talking about celestial mechanics and motion on the sky, so we're going to get through that first. So, I am roughly following the book Horizons by Seeds and Backman, but if you don't have the Horizons book, that is okay. There is probably a corresponding chapter in whatever book you're looking at, so just feel free to reach out to me. And also, as I really tried to emphasize before, my goal for this course is to be interesting and exciting for you and not really being that boring or stressful. So if you have any trouble at all worrying about what's important versus what's not, just reach out to me. But as I said before, the most important stuff, in my opinion, is going to be in the PowerPoint slides. So a recurring theme from this chapter is going to be the concept of perspective. What do you see from your vantage point, whatever it may be? So some things that you see, your perspective could potentially be affected by your location. Where are you standing on the Earth? Are you at the North Pole or equator or somewhere else? Your perspective could also be affected by any motion you might have. Your perspective might be affected by what you are looking with. If you think about your eyes take in visible light and your brain then interprets that visible light. But if I have an object that is giving off lots of light in the UV colors or maybe in the radio colors, I won't be able to see that object with my eyes because my eyes cannot see UV colors of light or radio colors of light. But I could at the same time build a telescope, build a camera that can detect those specific colors of light. But what you could see is based in part on what you are looking with. What you see could also be affected by the time that you look, and what you see, your perspective could also be affected by your location. But here I'm not only talking about your location on Earth, but where in the solar system are you looking at? Where in the galaxy or in another galaxy are you looking from? So, humans have been looking up at the sky since our species began, and probably before our species, some of our predecessors, noticing stars in the sky, and we tended to make up constellations based on the patterns of the stars that we would observe. And when we make these patterns in the sky of constellations, the stars themselves that make up a constellation are very, very seldom actually physically related to each other in some way. So as an example, here's the constellation Scorpio, the Scorpion. Now, the two stars in the tip of the Scorpion's tail look very close to each other on the sky. Here's the star Shala, and here is right next to it the star Jabba. Now, these two stars look very close together, but they actually aren't. In actuality, Shala is about 100 light years further away from us than Jabba. They just happen to be lined up almost perfectly between the Earth and then Jabba, and then Shala. So to get a context of how far apart these stars are actually separated, think about the video we watched from the previous chapter. If you think of the Sun and the nearest star, Alpha Centauri, as being two peas that are separated 129 miles apart, now let's extrapolate that. The Sun and Alpha Centauri are only a little more than 4 light years away. So these are like two peas being 130 miles apart. But now let's make that distance 25 times greater. So we're talking about over 3,000 miles apart and two peas. So Shala and Jabba, even though they almost line up from our perspective, they actually are not related to each other in any meaningful way, other than they happen to be the tip of the scorpion stinger from our perspective here on Earth. Now, what about constellations? In 1928, the International Astronomical Union, the official astronomical body of the world, decided to recognize and formally designate 88 constellations in the sky. The IAU also designated boundaries between these constellations. 48 of these constellations that were recognized date back to ancient times, while about 40 of them were from more modern times within the past several hundred years, compared to constellations that were known to the Greeks, Romans, and other cultures from long, long ago. Of the 48 constellations that date back to ancient times, many of those are the relatively more famous constellations that we have seen in one form or another. In addition to the constellations of the zodiac that we have all heard of before, there are also Cassiopeia, the Queen's Chair, which looks like a large W and is reasonably easy to find in the Northern Hemisphere. There is Delphinius the dolphin that is visible in summer and autumn in the Northern Hemisphere. And there is Orion the Hunter that is considered to be a wintertime constellation in the Northern Hemisphere. Even though Orion is not explicitly drawn in this picture, the three stars on a diagonal moving up and to the right over here make up Orion's belt. Then up here, this star and this star make up the shoulders of Orion the Hunter. Down here and here is the bottom of Orion's kilt as he goes around and does the hunting. And then hanging vertically downward from the belt, these three objects, two of them are stars, one of them is a giant cloud that is visible from Earth, is the sword of Orion the Hunter. Now, for the 40 constellations that were created in more modern times, many of these constellations are found in the Southern Hemisphere. The reason for that is there were many cultures in the Southern Hemisphere. They certainly all had their own constellations and patterns of stars in the sky, but there was no widely accepted this particular pattern of stars make up this constellation. So these constellations were formed in more modern times. So we'll say after the 1700s. Some of them include the Southern Cross, which is sometimes referred to as Crux. There was also the Chameleon and Microscopium, which obviously is a very modern constellation. And in addition to that, there are 5 nations of the world that have the Southern Cross on their national flag. There's New Zealand, Australia, Brazil, Samoa, and Papua New Guinea. Now, I was fairly loose in the last 2 slides when I was talking about constellations. In addition to what I said, the word constellation itself does have a specific formal meaning. And asterism is a pattern of stars as not one of the official 88 constellations as recognized by the International Astronomical Union. The IAU said these 88 patterns of stars in the sky are constellations, and any pattern of stars in the sky that is not one of these 88 is an asterism, is not a constellation. For example, one of the more famous asterisms is the Summer Triangle. 3 of the brightest stars in the sky, Vega, Deneb, and Altair, make up a large triangle in the summertime sky. Another famous asterism that you're all more familiar with is this one. So if you take a minute, you look at it, you might recognize that this is the Big Dipper. The Big Dipper itself is not a constellation. It forms part of a constellation. The Big Dipper, the handle of the Dipper, and the cup of the Dipper form the tail and back half of Ursa Major, the Great Bear. Now, stars themselves have names, and there are a lot of stars in the sky, and consequentially, there have been a lot of stars that have received proper names. There's Betelgeuse, Alnitak, Alnilam, and Mintaka make up Orion's belt, Rigel. There's Dubhe and Merak and Phecda and Megrez in the Big Dipper, among others. But naming all the stars and remembering all these proper names would become very tiresome very quickly. So instead, an alternative and potentially more convenient naming system for stars is to assign a star's name based on the constellation that the star is found in and the relative brightness of that star compared to other stars in that same constellation. Now, remember that all the constellations have boundaries. So here, if you look at the constellation Coma Berenices, you have these 3 stars make up the constellation of Coma Berenices. And this star right here, even though this star is not one of those 3 stars that make up Coma Berenices, the constellation, it still resides within the boundary of Coma Berenices, so I could still consider this star part of that constellation for the purpose of naming it. So the convention that is used is the brightest star in the constellation will be designated by the first Greek letter of the Greek alphabet, alpha. The second brightest star in a constellation will be designated by the second letter of the Greek alphabet, beta, and so on down the line. And the Greek letter will be followed by the possessive form of the constellation's name. So for example, if we look at Leo the Lion, Alpha Leonis will be the brightest star in Leo the Lion, so here's Alpha Leonis. The second brightest star in Leo the Lion will be Beta Leonis. The third brightest star in Leo the Lion will be Gamma Leonis. The fifth brightest star in Leo will be Epsilon Leonis, and so on down the line. Now, there are exceptions to these rules that we stated above. Often these exceptions are due to tradition or the preference of early star map makers who just couldn't be bothered to actually have the brightest star be the alpha star. And these exceptions, many constellations, the majority of them have at least one or two exceptions in them. But this is still a general trend that is used. For example, in Gemini, the star Pollux is about 40% brighter than the star Castor, but Castor is still designated Alpha Geminorum, while Pollux is designated as Beta Geminorum.